Hello everyone. I'm Dr. Shiv Kumar, Head of the Department, Civil Engineering, GIMS Engineering Management Technical Campus, Greater Noida. So in this lecture, we'll discuss about the trusses and arches. As we all know that the trusses and arches are one of the most important part of the civil engineering. So we'll talk about the material, their construction, the details, and how they look. So let's start with the trusses. So trusses are the key engineering feature in the emerging civil engineering content. Indeed, long span structures with lightweight is the main reason for the increase in the demand of trusses in the construction industry. Since from the usage of steel as a construction material due to its higher strength with lower mass, trusses took a major role in the civil structures together with the advancement of the steel industry. Over the past years, and even for now, considering aesthetic features, these trusses are made with a timber plank as well as roof truss, bridges, electricity, telecom towers, and even the structural frame are making use of these trusses as their integral structural form. So, as in the Delhi NCR, if you have seen the metros or metro stations, then you will find that the roofs are built over the trusses. Now, come to the definition part of the trusses. So, trusses are the simply defined as triangulation of members to make the stabilized structure. Triangulation is a stable configuration mathematically. Generally, a truss has the member called as top chord, bottom chord, vertical chord, and diagonal chord. The main function of the trusses are to carry the load from the overstructures, providing adequate lateral stability to the entire structure. So here we can see a bridge which is built by the truss, steel truss. There are some basic assumptions in the designing process. It should be clarified that construction of the trusses should conform with the design assumption to avoid the unwanted failure due to the dispersion of the forces and loads. The following are the assumptions in the truss design, like vertical members. Here we can see that the vertical member, this is the upper chord, and here we can see that the panel length between the two circles or between the two joints. Here we can see that diagonal member. The diagonal member is that you can see this is the diagonal member, and this is the bottom chord as the upper chord. And here we can see that the clear span between the first circle to the last, this is called the truss span. So all these have to be followed while designing of the truss. Now the truss member will carry only the axial forces. The nodes, that is the connections of the members, are designed as pin joint so that movement won't be transferred to the member of the truss. All the external loads and the reaction are act only on the nodes. Generally, the truss should be in the plane. So these are the basic conditions which we have to understand while designing the truss. Typically, the members of the trusses are made as I sections, angles, T sections, tube sections, square sections, and channel section. I sections are more preferable as an optimized section in the terms of the structural forces. Because I sections are previously used since a long ago, and it is durable and having the good strength. Now come to the simple truss. Simple truss indicate a single triangular truss. These trusses are most often used as the roof truss. Now the second is the planar truss, as the name implies. It is a two-dimensional truss. If all the members and the nodes are in a planar surface, then this truss is known as the planar truss. Next is space frame truss. In contrast to the planar truss, the member and the nodes are located in the three-dimensional space. Electrical, telecom towers are one of the simplest example that we are seeing in the day-to-day life. So space frame trusses are generally uh, recommended in the case of electrical or telecom towers. There are some more forms of the trusses. Which one is first one is the pret truss. The pret truss form the load in the gravity direction, and pret truss form for the uplift loads. So here we can see in the first and second image, this is known as the pret truss. The first one is the load in the direction of gravity, and second one is the uplift load or the uplift load. Next is the Warren truss. This Warren truss is shown in that figure in the third image, and north light truss. As you can see in the triangular shape. The next is the Virendale truss. The king post truss, bowstring truss, queen post truss, flat truss, lenticular truss are some other form of truss in the use of the industry. Here we can see that these are in the center. They can see the king post. Here we can see in the pret truss the king post. So this is the forms of the truss. Now we can see some other type of truss, like this is king post, this is queen post, this is multiple king post, this one is pret truss, this is how truss, this is long truss, burr arc, town lattice, and bowstring. The bowstring is provided generally in the bridges. So here we have seen the different kinds of truss which is being provided in the civil engineering construction. Some of the trusses are specially made for the telecom and electrical towers. Rest other are provided in the roof, basically. So now we will discuss about the arches. As we know that the arches are provided over the opening in a wall. That opening may be used as a windows and sometimes as a door. So types of arches based on the shape, their material of construction, their workmanship. There are a number of centers, and based on that, the arches are classified. An arch is constructed in curved shape due to which load from the above distributed to support pier or abutment. So arches basically provided over an opening which is known as the door and the windows. There are some types of arches which will be classified under, like shape of the arch, number of the centers, workmanship, and the material of construction. Let's start with the types of arches. The first arch in this series is the flat arch. This is one of the most common arch. For flat arch, the intrados is apparently flat, and it acts as a base of the equilateral triangle, which was formed by the horizontal angle of 60 degree by skew backs. So these are the skew backs, and this the intrados which is mentioned in that point. Even through the intrados is flat, but it is given that the slight rise of the camber of about 10 to 15 mm per meter width of opening is allowed for a small settlement. The extrados is also horizontal and flat. Here you can see that the extrados. These flat arches are generally used for the light loads and for a span up to 1.5 meter. The next is the segmental arch. This is the basic type of arch used for building in which center of arches lies below the springing line. In segmental arch, the thrust transferred in inclined direction to the abutment. So these are the abutments and it is transferred in the inclined direction. So here we can see that the segmental arch is here we can see the curve. This is made up of brick. Now come to the semicircular arch. The shape of arch curve looks like semicircular and the thrust transferred to the abutment is perfectly vertical direction. Since skewback is horizontal in this type of arch, the center lies exactly on the springing line. So here we can see that the springing line is there and here we can find the center which is at the springing line. These are the abutments and this is the semicircular arch. In the second image you can see. The next is the horseshoe arch. The horseshoe arch is in the shape of horseshoe, which curves more than semicircular. This is generally considered for architectural provision. In the first image here, you can see that the horseshoe shape arch and the pointed arch. The other name of pointed arch is Gothic arch. This is the type of arch. Two arcs of circles are met at the apex and triangle is formed. This may be either isosceles or equilateral. So here we can see that the pointed arch, why it is named as the pointed, because the point is above the springing line, it's the rise is too high and it makes the point. That is why it is known as the pointed arch. Now the Venetian arch. The Venetian arch is also pointed arch, but its crown is deeper than springings. It contains 4 centers, all located on the springing line. So here we can see that the here, then here, this one. So these are the centers lines over the springing line. The next is the Florentine arch. The interiors of the arch is in the shape of semicircular and the rest of the arches is similar to the Venetian arch. It has 3 centers, all located on the springing line. Here, this is the springing line. The one center is coming from this line, second this line, and first one and in the center line of the middle of the arc. Now the relieving arch. The relieving arch is constructed above flat arch or on a wooden lintel to provide greater strength. In case of relieving arch, we can replace our decayed wooden lintel easily without disturbing the stability of the structure. The end of this arch should be carried sufficiently into the abutments. So here we can see that this is the flat arch. Over the flat arch, we have provided this relieving arch. Now the next is stilted arch. Stilted arch consists of a semicircular arch with 2 vertical portions. Here you can see that this one is the vertical portion in the second image. Here we can see the vertical portion. So these are the 2 vertical portion which is discussed in the point. And here we can see that the semicircular arch with 2 vertical portion at the springings. The center of arch lies on the horizontal line through the top of the vertical portion. So main load is come over the abutments. The next is the elliptical, semi-elliptical arch. This is a type of arch of semi-eclipse shape and having 3 or 5 centers. The types of arches, here we can see that the semi-elliptical arch, it's not the perfectly elliptical, it rises and then again flatten and acquire the shape of this eclipse. So now we'll talk about the types of arches based on the number of centers. So in this series, the first one is the one-centered arch. The segmental, semicircular, flat, horseshoe arches and stilted arches are one-centered arch. In some cases, perfectly circular arch is provided for circular windows, which is called as bull-eye arch. It also comes under these three categories. So here we can see that the center in the image. Now, two-centered arch. The pointed or Gothic or lancet arches are generally come under this type. So we can see that the center over the springing line, these are the two centers. Next is the three-centered arch. The semi-elliptical and Florentine arches are generally having three numbers of arches, centers, like this one, and this one. Here the center, here's second center, and the third one. The four-centered arch. The Venetian arch is the typical example of the four-centered arch. Tudor arch is also having four center. Here we can see that the first, second, third, and then fourth center. So here are the four-centered arch shown in that figure. Now, the five-centered arch. Here you can see in the semi-elliptical shape contains five center. It's shown in the figure. Now we talk about the types of arches based on the workmanship and the type of construction material used. So based on the material for the construction and workmanship, the arches may be classified as the stone arches, brick arches, RCC, steel. So there are different kinds of arches. Like first one is the stone arches. Based on the workmanship, these are subdivided into two types. The first one is the rubble arches, which is made up of the stone. Rubble arches are very weak and used only for interior works. These are used at a span of 1 meter. These are made up of rubble stones, which are partially hammer dressed roughly or to have the rough shape and the size, and the fixed in cement mortar. Sometimes these are also used as the relieving arches up to the depth of 37.5 centimeter. But these are constructed in one ring. If the depth is more, then we can go for two ring in the alternate course of the headers and stretcher. Next is the Ashlar Arches. In this type, stone are cut to proper shape of voziers. Here we can see that the voziers, a wedge shape or tapered stone is used to construct an arch, and fully dressed joint with cement mortar. Ashlar stones are also used to make the flat arches. Here in the first image you can see the stone Ashlar arch. Now come to the brick arches. The brick arches are also subdivided into rough brick arch, the first one. These are constructed with ordinary bricks without cutting to the shape voziers. The arc curve is provided by forming wedge shape joints and greater thickness at extradoors and smaller thickness at intradoors. So it looks unattractive. That is why it is not recommended for the exposed type of brickwork. Here you can see that the joint is on the upper side it is wider and the narrower in the intradoors. The next is the X brick arches. The bricks are cut into well shape with the help of brick X. So these are roughly dressed in shape and size. Hence, arch formed by these X bricks are not very pleasant. Here you can see in the first image. So these bricks are wider at the upper end at the extra doors and the narrower at the inner end, which is known as the intradoors. The ghost brick arches. In this type, arches brick are cut to exact shape and size to required voziers with the help of wire saw. The brick are finely dressed and these bricks are joined by lime putty. But for ghost bricks, arches, only soft bricks are used. Here you can see that the ghost brick shape arch. The next, purpose-made brick arches. The bricks are manufactured matching with the exact shape and size of hosieres to get the very fine workmanship. In the first image, you can see that the purpose-made brick arch. The next is the concrete arches. The concrete arches are of two types. First one is the precast concrete block arches. And in the precast concrete block arches, the blocks are cast into molds to the exact shape of the size of hosieres. For keystone and skew backs, special molds are prepared. These will give a good appearance because it exact shape and size. The cement concrete is used as 1:2:4. So this ratio has to maintain to make the better strength of the precast blocks. The next is the monolithic concrete block arches. The monolithic concrete block arches are suitable for larger span. These are constructed from cast in situ concrete. These may be either plain or reinforced depending upon the span and magnitude of loading. The formwork is used for casting the arches. The curing is done for 2 to 4 weeks to make it or a better strength. So this is all about the trusses and arches which we have discussed in this chapter. In the next chapter, we will talk about the domes. Although it can be covered in this lecture only, but as a dome are the different comparatively and need to be discussed in detail. So we'll talk about the domes in the next lecture. Till then, thanks to all of you for listening and sparing time for this lecture. Thank you.